Oumuamua is not the only interstellar interloper. If you follow space news, then you will have definitely heard of Oumuamua, a visitor from another planetary system. This object, discovered in 2017, was the first ever object to get an interstellar designation from the International Astronomical Union. But interestingly, we actually know about a few more of them. So what are these objects? How do we know they came from beyond our solar system? And what are they doing now? I'm Alex McColgan and you're watching Astrum, and together we will examine what we know about Oumuamua and the other interstellar interlopers. There are a lot of predictions in the science community as to how many extrasolar objects pass through our solar system. Some think we regularly see visitors, with up to 10,000 per day passing within the orbit of Neptune. That seems like a lot, so let's figure out why scientists think this figure is so high. The first thing to understand is that our solar system extends way beyond the orbit of Neptune. Beyond Neptune is the Kuiper belt, and beyond that is the Oort cloud. The Oort cloud contains potentially trillions of comets that are gravitationally bound to our Sun. Some of the comets that we see that pass by the Sun likely came from and will return to this Oort cloud with their extremely elliptical orbits, taking tens to hundreds of thousands of years to do so. Some of the comets we see from the Oort cloud would never come to the inner solar system were it not for massive third bodies which perturb these comets' orbits with their gravity so that they fall towards the inner solar system. These third bodies are often other stars. You see, the solar system is not stationary like we sometimes may perceive, but we are constantly moving, orbiting the galaxy. As we move in our orbit, we cross paths with the gravitational influence of other orbiting stars. Even distances of a couple of light years can be enough to perturb a comet so it comes crashing down towards the Sun. On the other hand, it can also be enough for the comet to be pulled away from the solar system altogether, joining the ranks of the hundreds of trillions of interstellar interlopers found in the galaxy. As an Oort cloud-like body is likely not unique to our solar system, it must mean that comets are constantly being lost and others are being captured by stars throughout the galaxy every day. Although generally speaking, what we've seen of Oort cloud objects so far imply that the majority of comets in our Oort cloud did originate with our Sun, because they are mainly quite similar in composition. As the solar system travels through the galaxy, we also cross the path of interstellar interlopers that have been pulled away from their original home systems. They often approach from Vega, because that's the direction our solar system is heading through the galaxy. While the Sun does capture some of these objects, most are traveling so fast relative to us that they pass right through the solar system, only having their direction of travel changed as they pass by the gravity of the Sun. Oumuamua is one such object. It was originally thought to be a comet when it was first discovered, and got the classification C2017U1. But upon further investigation, it was reclassified as Asteroid A27U1 when no coma around the comet could be seen, becoming the first object to ever get a reclassification like that. Once the orbit of Oumuamua had been established, it also became clear that it was traveling too fast for it to be in orbit around the Sun. We say that the object like this one has a hyperbolic trajectory. Because its velocity will see it leave the solar system altogether, it likely didn't come from the solar system to begin with. The International Astronomical Union had the unusual task of having to create a new classification of object just for Oumuamua. They decided upon I for interstellar, so Oumuamua's designation is now 1I2017U1. Oumuamua is unusual for a number of other reasons. As it is like an asteroid, it must have originated from the inner part of its home system. So how did it get ejected and make its way to us? Is it from a collision of huge proportions? Alternatively, Maybe it really is a comet, but as it traveled through interstellar space over millions or billions of years before it got to us, it has been coated in dust, meaning that the volatile materials typically found on comets weren't exposed to the sun. The other weird thing is its shape. I've always seen Oumuamua referred to as cigar-shaped, but because it is less than 1 kilometer long and only around 35 meters across, even the most powerful telescopes couldn't resolve more than a pinprick of light. It's been given this shape because its brightness pulsates over its 7-hour rotation period. This is because we receive more light from its reflection when it appears longer from our perspective. However, this could apply just as easily to a saucer-shaped object. It also appears to be tumbling rather than rotating along a set axis. Its shape and rotation could lend weight to the theory that it originated from a collision. Another weird attribute is that it accelerated away from the sun, only by a tiny amount, but more than it should have if it really was a non-volatile asteroid. So now, some scientists think it might be more comet-like after all, and that it was ejecting only gas rather than gas and dust, like we normally see from comets. However, mysteriously, no coma or tail was ever detected. To be sure, the Spitzer infrared space telescope spent 30 hours trying to get any kind of reading on it, but couldn't, meaning this object emitted nothing in the infrared. Typical comets have comas and tails that Spitzer can spot, like in this image. If there was an acceleration, but it's not a comet, then what caused it? This point in particular got people thinking that this wasn't simply a rock, and that there's maybe more of an alien origin to this object. This theory received more credibility when it emerged that this object was also 10 times shinier than a typical comet, meaning it reflected light like a metal. However, before you get your hopes up too high, SETI listened for any radio signals emanating from the object, and nothing was detected at all. Even the faintest half-watt signal would have been detected had it been there. So, at the end of the day, we don't have enough information to prove something either way, and it is now too far away for us to send a spacecraft after it. So I'll let you decide for yourself. It's intriguing though, nonetheless. But as I mentioned, we've also had other visitors from outside the solar system. But this next one is a little more conventional. Being the second I object, it's been given the designation 2I Borisov. Zooming in on Borisov reveals that this object had a big comet-like coma and tail, almost the size of 14 Earths across. We couldn't see it with the naked eye though, as the closest it got to the Sun was beyond the orbit of Mars in 2019. Borisov was roughly the same size as Oumuamua, about half a kilometer across. After its closest encounter with the Sun, it began falling apart. This is reasonably normal for a comet of this size passing by at this distance. Also, its composition, while uncommon, isn't particularly unusual either. Because it passed through the solar system at a greater distance than Oumuamua, its trajectory wasn't hugely affected by the Sun's gravity. So, overall, apart from its I classification, it's a somewhat unremarkable object. Now moving on to some other interesting interstellar objects that do not have the I classification. C1980E1 was originally a solar system object with an orbital period of 7.1 million years. The furthest its orbit used to take it was an incredible 1.7 light years away from the Sun. However, it passed a little too closely to Jupiter during its last approach in 1980. Jupiter's gravity accelerated it just enough for it to get a hyperbolic trajectory, and so this object will eventually become an interstellar interloper itself when it leaves our solar system in a few million years. On the other hand, we have had the opposite happen, where interstellar objects have had their velocities slowed down enough by the gravity of Jupiter that they became captured and locked into our solar system. Again, I mentioned Jupiter specifically because it has been determined that other planets aren't massive enough to do this, and it has to be a third body beyond the Sun and the comet that does the slowing down or speeding up. Machholz 1 and Hyakutake C 1996b2 are potentially such captured interstellar comets from another planetary system. The giveaway for objects like these are their highly elliptical orbits and their very unusual compositions compared to the majority of other comets. This makes them interesting and viable targets for future missions, as the solar system might have done all the hard work for us in capturing interstellar objects and putting them within arm's reach. There's one more giveaway that an object might have extrasolar origins, and that is if it is orbiting retrograde to pretty much everything else in the solar system. An example of an object like this is 514107 Kuiper Oka Avela. What makes this object especially interesting is that it is also an asteroid, unlike most other interstellar objects we would expect to see. It could also be that the volatile materials have already burned off if it was once a comet, meaning it would have been captured very early in the solar system's past. Its orbit is also unusual in that it is locked in a 1-1 orbital resonance with Jupiter. Now, if there really are plenty of interstellar objects passing through the solar system, it's clear that we need better equipment for detecting them. One of the new Vera C. Rubin Observatory's mission goals is just that. When it begins operations in 2021, it will use its wide-angled field of view to scan the sky for all sorts of asteroids, comets, and interstellar objects. Want to know more about this impressive project and what it hopes to achieve? Check out my video I made about it here. So there we have it. Although Oumuamua is beyond our reach, there are plans in place to have a spacecraft ready to go to visit the next one at a moment's notice. What secrets will we find on objects like this? Only time will tell. Subscribe for more space videos so you won't miss out on future updates on interstellar visitors. Thanks for watching, and thanks to my patrons and members who support the channel. If you find value in these videos and want to support the video production process too, check the links in the description to have your name added to this list. All the best, and see you next time.